Hey, hi, hello guys. Welcome back to Code with Nani channel. So today we're going to discuss the lead code problem of the day. Find elements in a contaminated binary tree. So you are given a binary tree with the following rules. So the root value must be equal to 0, and regarding that root value, we will be having a left child or right child. If the left child is present, then the left child value must be equal to the 2 into value of the root plus 1, and if it is a right child, that value will be 2 into value of the root plus 2. Note, if a tree is contaminated, which means all the values has been like what they are saying, trying to say is the binary tree has been contaminated, and all the values in that binary tree has becomes now -1. So what we need to implement, the classes are like find elements. So in find elements, so we need to retrieve the original values of the elements instead of a -1. So we'll be having a cases, right, like the root value must be equal to 0, and the following left tree will be the 2 into root value plus 1, and the right child will be a 2 into value plus 2. And we need to we also had another function bool find, which is like it has the target value. We need to return if the target present in the binary tree or not. If not present, we'll just return the false. So how do we approach the solution? So as we see, as you can carefully observe this problem, the given conditions are always the root value must be equal to 0, and the left child value equal to 2 into root val plus 1, and the right child, and the value of the right child is equal to 2 into root value plus 2. So if that tree doesn't has a left child, so you can directly skip that value. You can directly assign the right child value in 2 into root plus 2. So I'll give an example. So if you take the case, so we have a binary tree like this. Okay. So initially the value of this is 0 and left child is 1 and this is 2. As we don't have any child for this one, so we'll just simply skip it. And what is the value of this child? 2 into root value is 2 plus 1. This 2 into root value plus 2. Right? Did you get my point? So this will be 5 and this is 4, 5, 6. So this will be the binary tree. So what they are trying to say is, after some, due to some corruption in the data, and the binary tree has been contaminated and all the values has been shuffled to -1. So all the elements in this tree has becomes -1. So what we need to do is we need to retrieve back to this data. Okay. So how do we approach this problem? So think of a solution. So we can directly use, can, if you carefully observe the structure, you can directly use BFS or DFS. So while you are doing the BFS or DFS, you'll just store a value of the root. Sorry, you can just you can just store the root value, and just change the child left child and right child value by 2 into root value plus 1 and 2 into root minus. And how do you implement this find function? How do we implement find function? You can actually use another BFS to find the target present in the binary tree or not. But instead, what you can do is, if you really want to optimize your solution, while you are traversing to this BFS or DFS to to retrieve back the data in that binary tree, what you can do is you can just simply push all the elements into a set, or you can push all the elements into a map, so that when you are trying to find the elements, when you are implementing this find element, you can directly seek for that particular target that is present in the set or map. If it is present, we can directly return true, or else we can directly return false. So that's cool, right? So we can directly use the data structure and get to the answer in a of one time. You can implement that find function in of one time, or else the brute force way will be, you can implement another BFS and to find the target. If the target is present, you can directly return the true, or else you can return the false. So yeah, I'll just walk you through the code so that get clarity about the solution. So I'll just show you. I'll walk you through the solution. So what we are trying to say, as I told you earlier, first I'm just initializing the queue with a tree node star. If a root is not null, which means like if the root value is not a null, what we are trying to do is, as the question description says, the root value always starts with a 0. So that's what I'm doing. The root value is 0, and we are simply pushing into the queue as I told you earlier. So in order to execute the find function in of one time, we simply use a set or a map function to directly push the values into the data structure so that we can retrieve during our find function. So that's what I'm doing. I'm simply inserting that root value into our data structure. So I just created a data structure here and just pushing the values over here. So you got it right. So that's what I'm doing. So I'm just pushing the pushing the values into the set while that queue is not empty, which means we just make our root value is 0. We need to check for our left subtree and right subtree. If there is no left subtree, we can directly push the right subtree right child into the queue. So that's what I'm doing. I'm just storing that front of that queue part in a temp and just popping out from the queue. And we need to store this value because for that left shell, we need for left and right shell, in order to get the value we need to multiply it with the 2 into root value plus 1, right? So we need that value. So that's why, for that sake, I'm just storing into our value and just pushing that value into our set, because when we retrieve the values, we just push into the structure so that we can find it in the find function. So if temp left, which means like if temp left is not null, then the conditional statement will execute. Or you can even write if temp left not equal to null. I'm writing directly. Then temp left value will be 2 into value plus 1. What is this value? This is the root value. Okay. And we simply push that. What we need to do? We need to push that into our queue, because this if we push this element in the queue, then it will check for their respective childs, right? Then their respective childs. So and keep going on, and we'll same way we'll check for the right subtree as well. If right subtree is present, we'll just multiply with the 2 and we'll push it into the queue. And in the end, in order to uh, implement the find function, we just simply check whether the target is present in the set or not. If it is present, we'll simply return true, or else we'll simply return false. So once again, check my code. If you had any doubt, do put a comment in the description so that I'll help you out. And that's it for today video, guys. If you like the video, do subscribe to my channel, share it with your friend, and that is for today video, guys. See you, tata, bye bye, see you tomorrow.